Are you ready?
No.
I'm going to show you how the range of optimality is calculated. And I'm going to slide, let's see, where am I going? Slide 6 if you have to go work this out. Remember this?
Feasible region.
We did this whole problem, we graphed the lines, we found the extreme points, we found the feasible region, right? And then we identified the binding constraints. And once you can identify the binding constraints, you can use the binding constraints with the objective function to calculate that range of optimality. Now I'll make sure you know what we're about to calculate. Let's see, which one is this? This is 819, correct? So is this one say 819? This one right here. Solution, solve. We're about to calculate, 5 is in the objective function, what it could go up to, what it could go down to before that optimal solution would be changed. 7's in the objective function, the 7 could go up, the 7 could go down before that optimal solution is changed. And how that's done, it's there in the PowerPoint. I'm struggling whether it'll be on your quiz or not, so you know, you can tell me after we're done whether it should be on there or not. That's another problem. Yeah. After we're done, keep an open mind.
So if it's on the quiz, we'd never have to see it again, right?
It could be on the final though.
No, not if it's on the quiz. If it's on the quiz, we'll never have to see it again, right?
True.
It's possibly true, yes. If having to calculate the rate of optimality manually is on the quiz, I would imagine there's no way you'll ever see it again.
Put it on there.
Hang on, keep it open mind, both directions. Right? You guys decide, take a look at it real quick. So right now you've got to this point, and you said, my binding constraints is the one less than equal to 8, less than equal to 19. You identify it. Look at the numbers with the variables. Look at the numbers with the variables in the objective function. You take the number with the first variable and you put it over the number with the second variable and make it negative. And you just found the slopes. You ready? I'm going to start with, hang on. I'm going to start with that less than equal to 8. You guys tell me, and I want to say one more thing. You put the slope of the objective function in between the slopes of the binding constraints.
That's the slope. You just put them in the slope intercept.
What's our line talking about? This one in the middle?
Yeah.
That's the objective function line that we kept moving outward, outward, outward to find that optimal solution there. And that's this right here. We made it equal to some arbitrary number. Yeah. Okay. So we like made it equal to 35 or something like that. What numbers? This is not a trick question. I just want you to participate here. What number is with the variable x in the objective function? 5. What number is with the other variable, which is x2, in the objective function? 7. Make it negative. That goes in the middle. You identify the binding constraints. What number is with x1 in the less than equal 8 binding constraint? 1. What number is with x2? Make it negative. Put a little equal there. And I'm putting a little equal here. And now look at the other binding constraint. Tell me what numbers with x1 in the other binding constraint. 2 over 3, make it negative. This is easy to set up, hard to remember. All right, everybody's with me? Here's the part that if you try to do this on your own, you're going to have to read it a few times because it's kind of confusing the way they word it. So I'm going to break it down here real quick, as easy as I see it. As easy as I can make it easy. I'm going to take F5, and by getting rid of it and turning it into a variable, any variable, the PowerPoint says make it C. Any variable you want though. And now if I use algebra to get that C all by itself in the center, getting rid of the 7, getting rid of the negatives, the result on each side will be what that 5 could go up or down to by just turning it into a variable. And then I come back and I'll take the 7 and turn it into a variable. So I'm going to do this twice. So I'll make that C1 and this one C2. I got to do it twice. And the 5 is back, but the 7 will be a variable. And I use algebra to get that all by itself. And it will result in what it could be, go up or down to. Sounds crazy. You ready? Here it is. The 5's been made a variable. C1. It's a negative. I want to get rid of that 7, and it's being divided by 7, and whatever I have to do to that to get rid of the 7, I have to do to this whole equation. You can't just do anything to part of it. Whatever you do to all of it. So I'm going to multiply the whole thing by 7, right? And I'm going to go a step farther. I want to get rid of the negative. So if I multiply the whole thing by -7, I'm doing both getting rid of the 7 here, and I'm getting rid of the negative at the same time. So I'm multiplying the whole thing. Let me start in the middle. -7 times -c over 7. Now remember, this is the same as like 7 over 1, so you can cross multiply. 7 times c, negative times negative is positive. 7 times c is 7c. Over 7, the 7's cancel each other out. All you have left is c. That's why we multiply by -7. Now, over here on the right side, this is like 7 over 1. Negative times a negative is gone. 2 times 7 is 14. 3 times 1 is 3. All you get, you can leave it like that. I always turn it into a decimal. But you can leave it like that. It's 3 point, what does it say? What is it? 3 point calculator. Am I getting Siri? Siri, do I have to talk to you? Sorry, go ahead. 4.6? 4.6? Oh, yeah. I thought it was 5. 4.6, right? There's that one. 1 over 1 negative. Negative and negative cancel each other out. 1 times 7 is 7. 1 times 1 is 1. 5 could go as low as 4.6, as high as 7, and the optimal solution is still valid. Is that what the output says? Let's take a look. Does it have 4.666? Yeah. There. 7. All right. Help me through the next one now. Hang on, let me get back to PowerPoint. Okay, I do this all over again. I put the 5 back, and now I'm turning the 7 into a variable. -5 over C2 equals -1 over 1. Nothing else changes. -2 over 3. Nothing changes. I always, you can do what you want, but I always make the first step when the variable's at the bottom as a flip. It just makes it so much easier for me. So my first step is always to flip. You flip everything. -1 over 1 is still -1 over 1. Now I have -c2 over 5. Now I have -3 over 2. As long as you flip all of it, and not just one part, the equation's still the same equation, just been flipped. Now I know I can multiply by -5, just like I used -7 up here, and I'm getting rid of that 5, and I'm going to get my results. So I'm taking the whole thing by -5. That's the same as -5 over 1. Here in the center, I did -5 purposely to get rid of this dividing by 5. That leaves me with just the variable. On this side, I have -3. Negative times a negative is positive. 3 times 5 is 15. 1 times 2, that's 15 over 2, which is 7.5, I think? Yeah, I think so. 1, negative times negative is positive. 1 times 5 is 5. 1 times 1 is 1. The 7 could go as low as 5 and as high as 7.5. Let's see if that's true. As low as 5 and as high as 7.5. Does everybody see how that's calculated? So that's on slides. On the PowerPoint, this is demoed. It starts kind of on slide 6. 7 is kind of describing using variables. It's saying take your objective function, put the number over that number. That's what it's trying to tell you here. But make it negative. Then use the binding constraints, putting the number over each other like that for each of the binding constraints. And put the objective function between them. So, where are we here? The objective function between the two binding constraints, we use -1 over 1, same thing. We had -5 over 7, but we turned the 5 into a variable. And there's -2 over 3. Multiply the whole, right here, multiply the whole thing by -7. You get 14 thirds, just the C1 by itself, and 7. So 5 could go as high as 7 or as low as 4.6. So there it is on the PowerPoint. A lot of people kind of get confused on it, but it's not really that hard. You just got to remember the part where you take the numbers with the variables and put one over the other, and you got to stay consistent. I made x1 the top all the way over. Had I made x2 the top all the way across and x1 the bottom, same results, no different. As long as you're consistent, do the same variable numbers with the variables, and all 3 equations are at the top, all 3 at the bottom. So as long as you're consistent. You ready? Next. we're going to, right here, sunk costs and relevant costs. Last night I was starting to think about maybe you guys would like some examples, and as I was going through the examples, I can see where something's kind of relevant cost and something's sunk cost depending on the circumstances. I'm going to go a generic definition for you, and to kind of say, look, if you want to get to examples, yes, please read about it more. But I know you got the quiz on Tuesday, and to prepare you, it's all about what these mean when you're calculating and for this quiz. And here's the difference. Sunk cost. If something's a sunk cost, and here's what it's used, is these 619.8, they represent resources. I'm going to use raw material, same as we did a couple days ago, as an example. Let's say this is 6 tons, 19 tons, 8 tons or something. If the supplier calls you and says, hey, we've got an extra ton, right? You need to quickly make a decision whether you're going to buy or not. Now, this is real life. You got to make a decision because you're being presented with, here it is, we're in the area, this other customer didn't take it, we're driving right by, we're going to give you a price you can't refuse, at least they think. And for you to make that decision, you got to, here's your steps. Number 1, is this extra material, or whatever the situation may be, within the limits? So first step, look to see if it's within the limits. If they offered us an extra one, is it within the limits?
Yes.
Because you could go as high as what? At infinity. That's right. They can drop off as much as possible, and we can take it and use it, depending on the price. Are you ready? Look at the dual price for that constraint, for that resource. And it happens to be, all right, we're going all the way back now to the second one, because there's no dual price. I didn't look. 19's going to 20. It has a dual price. First of all, is that increase of 1 unit being dropped off within the upper limit?
Yes.
Yes. Look at the dual price. The problem's going to say, I want to read it right. This cost for that resource is not already in the objective function. Therefore, that dual price, which is what for this constraint? You see it exactly. Is the most you would pay for an additional unit. That's what it represents in a decision when a resource is being talked about. That's the most you're willing to pay if it's a sunk cost. And you'll be clear in the question. If it says it's a relevant cost, or the words, you ready? In fact, I'm taking these right off your PowerPoint, so I'll take you to it. Slide, I don't have a slide number. Anybody see it? Yeah,
down the bottom left.
there it is, right here.
Slide 13.
13, let's go with, I think it's, is that the only description right there? All right. The sunk cost, if it must be paid regardless of the amount of the resource actually used by the decision variable. Is that where we're at? Sunk cost, not already in the objective function, therefore the dual value equals the max you would pay for it. I can see that in that sentence right there. There it is. It's not reflecting the objective function variable. So it should say, and it is the most you would pay for 1 additional unit. Relevant cost is the opposite. Relevant cost already reflected in the objective function, meaning this cost has already been calculated in that objective function. Like maybe the objective function equals gross profit because the cost of this resource is a variable cost, for example, and we would only pay for it if we got additional units. But that margin already takes that into consideration in the objective function. I'm just explaining to you so you know what it is, but here's the deal. If the question says this, resource call and they have an additional unit, we're looking at 19 again. Number 1, they want you to buy that for $3 a unit. And they got 1 additional unit. What's the dual price? And 3's over it, right? And it says, and it's a relevant cost because the cost is already in the objective function. Hear the words? I'm not going to trick you. I'm going to try to put relevant or sunk in the question so you're not tricked. And if it says it's a relevant cost, that dual price represents the most you're willing to pay premium premium over and above the regular price. And the problem will say you usually pay $1 per unit for this resource. They're offering it for $3 a unit. Now, who's with me and can tell me yes or no, would you take it?
Yes.
Are you all with me? All right. But you want to take this farther and make me really happy. You say it's at the max because we usually pay $1. This represents the premium over the regular price, so 2 + 1 is 3. It's being offered to us for $3. So even though it's over the dual price, now because it's a relevant cost, it's still not over the premium over the regular price, right? The premium, the most we're willing to pay premium is that $2. So if it's $3 or less they're offering it to us for, you're saying yes. $3 though on the nose is a break even. So that's where you as a buyer have got to renegotiate. Matter of fact, you renegotiate on the spot no matter what. Make me proud, that's your job. You always negotiate with those suppliers, period, especially in these circumstances, because you know how bad they want that off their truck? Just as bad they think you want it, or worse, because they don't want to take it back to the Flint. That was supposed to be somebody's. They want it off that truck. You renegotiate, but the answer is, if they're offering it for the regular price plus the premium, as long as those two add together, they're offering it for that or less, you're saying yes. You know, but I don't know if I'd say yes at a break even, but why not?
Is that what you would expect from a response from us then?
Yes.
Yes, I would take it.
Yes, I would take it because $3 is equal to or less the regular price plus the $2 dual price, which is the premium. All right, let's do it one more time. Have a look at it carefully. All right. The last resource currently has 8. The supplier just called and offered us an additional unit for $1 per unit. Do we take it, yes or no?
No.
Very good, Sean. What did you see?
Well, the upper limit's 8.
That's right. Did everybody see that? Everybody hear that? That was kind of a trick. I took it above the upper limit. It didn't matter what the price is, because that dual price is no longer valid. Once the decision takes us above that, hey, I know you're in a hurry, go ahead and offer it to someone else, because I got to redo this whole thing to figure out whether I can take it or not. You're outside my upper limit. And they'll know what you're talking about, because they deal with manufacturing buyers all the time. So, you know, you just say, and then they'll go, okay, we'll give you time. Call me right back. I'm going to pull over and eat lunch. I mean, that's life. That's how it really works. That's how it happens. All right? Got it? He just offered us additional, boy, a quarter of a unit. How's that? Has an additional quarter. This is constraint number 3. Supplier represented this limitation. We're expecting 8. There's a quarter of a unit being offered to us for, I gotta think, man. It's a sunk cost, and it's being offered to us for 22 cents. Do we take it? Why? Not just, yes, first thing you look at is within the upper limit. That's one reason, yes. What was the other reason?
And
Yes?
also your max price you're willing to pay is $1.
Why is that the max price? Because what did I say?
Because of the sunk cost.
Because it's sunk cost, that's right. And that's all you gotta look at, is the dual price. You don't care what the regular price is. And it may say the usual price we pay is $1 per full unit, but that doesn't matter. Because it says it's a sunk cost, you're looking at that right there and you're going, okay, this is the most we would pay for a full unit. We're being offered a quarter of a unit, so what's the most you would pay? 25 cents, because it's a quarter of a unit. It's being offered at 22 cents. You can pay, it's within the upper limit, and it's within the max we would pay as a sunk cost. So you say, yes, I'll take it after you try to renegotiate.
So then if you go back to the same thing for constraint 2, you would have said it was a sunk cost, you would say no?
Yes, that's right, because it was $3, and the most we're willing to pay is 2 if it's a sunk cost. Absolutely, exactly.
Are we gonna? So will everything be an even number? Or we're gonna have a quarter of a product, and then we have to
It'll
look at a
probably
quarter.
be an even number. I went to a quarter because.
Sure, sure.
Okay, you guys know. All right. How do we feel? We're okay? All right.
We're breathing.
Can you run through the
What did you read
relevant
on
costs?
Tuesday? All right, we're gonna go to, let's see.
Wait, I think Shane
All right,
has a.
I'm sorry, go ahead.
Yeah, can you go through the relevant costs for one, like?
The relevant cost?
Yeah, really.
Okay, you ready?
Yeah.
Should we, let's do the same supplier. This makes it harder. Let's do the same supplier. Right here. Going up a quarter of a unit, which we usually pay per full unit $1. It's a relevant cost. With me right now? And they're offering us an additional quarter for 33 cents. Do you take it? Let's show you answers.
I have no idea. I don't
Whoa,
know.
stop! What? Help her. What?
Quarter of a unit
Come
for
on.
33
We're
cents.
recording this. Who was here? Is there people here? Would you take it?
Yes.
Yes. Why? Someone wants to jump in with why. Brian?
Because you take the original price and you add $1 onto that.
That's right. What was the original price?
$1.
$1. What's the most you're willing to pay over and above that dollar because it's a relevant cost? $1. That makes it $2. How much is being offered to you? How much? What percent? A quarter of it. So the most you're willing to pay for that quarter would be a quarter of what he just calculated. A quarter of how much? $2, which would be how much? No, it's 50 cents, isn't it a quarter? Yeah, I guess it is, sorry. And it was being offered to you for 33. Is that why you should take it? Because the most you should be willing to pay is 50 cents for it. It was a relevant cost. You take into consideration the regular price we pay, plus the premium max, and that's the most. And then, you know, it'll probably be a whole unit, but in this case, it was a quarter of a unit, so a quarter of the most you're willing to pay, which was 50 cents. It was being offered for 33. We're taking it. After we try to renegotiate and get greedy, but 33 is a good price. We got a minute to try.
Is that premium, is that $1 no matter what, or did you find it somewhere?
The premium is always the dual price on top of the regular price. The regular price will be in the problem. And if it's a relevant cost, you got to add the regular price to the dual price. If it's a sunk cost, you don't care about the regular price. You only care about the dual price. That's the max right there. You don't
So
have
you
to
said the regular price was $1.
Yeah, $1. So Brian said add this dollar to that dollar, taking the premium plus the regular price, then that's the max for a full unit. And I was offering a quarter of a unit, so a quarter of the full price. Right?
Okay, I was gonna say words.
You ready? Huh?
Got it.
I don't, chapter 3 starts to challenge you guys, but you haven't seen anything until you get to chapter 11. If you skip chapter 11, you're crazy. Unless you watch the video. I don't know. You ready? We're going to another one here. Let's see, I want to go to this example right here. Whoop, right here. Let's see, we're going to slide, where's example 2? Going to slide 29. What is this? There we go. Oh, wait, here we go. Remember this plate problem? I almost forgot. Oh, hey, I know what I want to do right here. And I want to take this one, right? What's the name of this one? Doesn't even say. This is it. There we go. You see this? Oops. I'm going to solve it. This is it, right? This is the bike. We got aluminum. I think it was 100 units, 100 pounds maybe, was it? Pounds? Or tons? Pounds? Okay, 80 pounds of steel. Does that sound right? And the bike frames, $10 off the deluxe, $15 we would make off the, I can't remember the professional, I think was the other one? Yeah. All right, solve it. Let's answer the question on the PowerPoint. Looking at this output, as soon as hey, what did I just use? Come on. Up. Hang on. All right, it's touching. Let's just assume you can see that this is constraint 1 and 2. That's constraint 1 and 2 up there. Ready? PowerPoint says if the unit profit on a deluxe frame were $6 instead of, what is this? This is range of optimality. Amen. Did it switch slides on me? Or did I? There it is. There it is. There it is. There we go. You ready? Given that aluminum is a sunk cost, remember which one's aluminum? Is it constraint 1? Yeah. Okay. Given that aluminum's a sunk cost, look at your notes real quick what that means. What is the maximum amount the company would be willing to pay for 50 extra pounds of aluminum? What's the most the company would be willing to pay for 50 extra pounds of aluminum? Give me a number. 150 almost, a little more, but yeah. Nope, no. I'll say that again. $156.25. All right, you guys ready? You're looking at whether you will take it or not. which is absolutely the first step you have to do. You have to look and see if that dual price is still valid or not. So she's saying there's being offered 50 extra units, it's within the upper limit, and then he said the 50 extra units is a sunk cost, so all he had to do was multiply it times the $3.12.5 because that's the most we'll pay per 1 unit at a sunk cost. You didn't have to take the current price. Now, this is a quiz question. The only extra part will be the current price to be paid per unit of aluminum, and then you have to decide whether you need that information or not. So sunk cost, you don't care. Relevant cost, that information of what we're usually paying is very clear. You have to add it then to the dual price. So number 1, is it within the limits? Yes. Number 2, then calculate what's the most would pay, or would you say yes or no to an offer of $150 for these extra 50 units? Would you say yes or no? Yes. Because the most we're willing to pay, you said was 153. Hey, it's on the next slide. 156 and 25 cents. Because this is sunk cost, the shadow price. You've never seen those words. Shadow price is the dual price. Dual value on a different software says shadow price, dual value, all the same thing. The shadow price for our maximization problem, the shadow price of aluminum is the $3.12.5 per pound. The maximum allowable increase is 60 because the 50s within the range, $3.12.5 is valid. 50 pounds times it, there's the most we're willing to pay. They're offering it to us for 150. Your reaction, because you're new to the company, is to say yes, but then we have a meeting and I say you should have negotiated. I'm watching the tapes. You did not negotiate. All right? I'm videotaping all of you who work in my place. Yeah, it is, but we're not going to waste any money, are we? I'm not going to watch any money flow out the windows like all the other companies. I'm going to give it back to the employees for putting up with our efficiencies. Which reminds me, prepare for anything, because don't forget, don't get mad at me. I'm treating everybody the same, but I'm going to do everything I can to make sure the temptation to cheat is gone. All right? When you study this weekend, you got to say to yourself, I got to do my best on here, and I can't rely on anything I just had a conversation with the people around me, because who knows if I'm even sitting next to them when I get here. That's all I'm saying. All right, ready? Thank you, Casey. Let's go to the next one. And you know what? I think we got to do a quick review. I do think that may be possible. Supplier, aluminum. We have 2 offers on the board. We have 2 offers. Both suppliers, the aluminum and the steel, got a hold of us. And we're being offered an extra 3 pounds of aluminum. I gotta write this down. So aluminum is going to be an extra 3, and the steel is going to be an extra 10. Yeah. And the aluminum's being offered to us. These are both going to be a sunk cost. So I have to try to figure out the prices right now. And they're both being offered to us for, hang on, almost there, $9. Someone's going to give me a great answer. I can almost feel it already coming out of your pores. Thank you. You ready? And the other one, 10 times. So they're offering this for $10. $9 and $10 for 3 units and 10 units for this. Do we say yes or no? Do we take this or not? What's all the hesitation for?
Say yes.
Why? Wait. What's the first step before we confirm it?
Check the upper limits.
Check the upper limits is the first step. They're both being increased. Are they both within their upper limits?
Yes.
Okay. Step 2 is to do what?
Check the dual price.
No.
100%.
100% rule, you guys. That was what this whole problem. This is why I'm throwing this at you. This is exactly what you've got to say to yourself. If there's more than one change taking place, no matter if this is about what the price is, if there's more than one change taking place, you've got to say simultaneous changes. They're in the same category. They're both happening to constraints, range of feasibilities. You have to calculate the 100% rule. You have to. And if you just skip to checking the dual prices and skip that 100% rule portion, that is far too many points. When you look at the problem, you'll go, oh, this is 7 points. You're going to realize, I may not be doing everything here, because this doesn't look like 7 points in my answer here. Let that be your guide a little bit, that you may be forgetting something. 100% rule has to be done. Are you ready? I'm going to fly through this, because this is review, right? You ready? Aluminum's going up 3, so.
Can you erase some of
Yeah, thank you. Yeah, I can. One of these days I'll have someone helping me and they'll just erase it while I keep talking.
I don't think they could keep up.
Ready? 3 over how much aluminum could we have had offered to us and still be within our range? 60. Wow. Give me some math on that when you get a chance. 10 over how much steel could we have had offered to us and be within our range? 70. Don't forget, you always compare it to the direction the change is going in. As much as I emphasize this, every semester somebody's going to give you that full range as your denominator instead of just the direction the change is going in. These are going up, so just the amount they could have went up. Get it? Now, this percent, 3 over 60 is very low. Point what? 0.05, no?
0.05.
Yeah, 0.05. What's the next digit so I can check your rounding? Was that Brian? Who was that? Yeah, what's your next digit? Oh, it's only 0.05? There's no other digits? Oh, thank you. All right. 10 divided by 7 is like 1 over 7, which is 0.14. Wow, these are low. This adds up. You have to show me work that you compared it to 100% somehow or another. Something on here that shows me you did do the comparison, which would be the next step. This is obviously less than 100%, which means what?
Valid.
That's right. That the dual prices, that the dual values, that the shadow prices, whatever you want to call them, are valid. And now we can make a decision. Now the decision can be made. Do we take this, look at the aluminum, 3 units, $9, is that within the max we're willing to pay for aluminum per unit? Yes or no?
Yes.
Very good. What's the most we're willing to pay for aluminum per unit? 3.125, $3.12.5. It's being offered at how much? 9 for 3 units. That's $3 a unit. Yes. After you what?
Negotiate.
What?
Negotiate.
Try to negotiate. Exactly. I've got to drill that into you because that's going to be the thing that wins the job for you. Is that you're going to mention this in the interview. Yes, but I've tried to negotiate that. Oh, you just warmed an interviewer's heart. All right? This one's going up 10 units, the steel. It's being offered at $10. It's a sunk cost. Are you taking this one too?
Yes.
I hear yeses. How much is the max you're willing to pay per unit? $1.25 times 10 would be $12.50. It's being offered for $10, which is less than $1.25 a unit. You say yes right after you negotiate. All right. All right. You guys, that was a great review. We need to do one more. You ready? All right, we're going to slide 33. We're going to slide 33. I can see. 33, right here.
Got a question?
All right. Let me get to here. Whoop, whoop. Hang on, I gotta do this little thing. There we go. Go ahead.
That chart that has all like basically the word problem, can you just post that online so we have to refer back to?
What chart's that?
The one we've been working on with just now.
That PowerPoint?
The solve part. The solve.
This right here?
Yeah.
This, Henry showed me how to post this on Blackboard. It's right there on your page.
Oh, it's already there.
It's there, right there. It's a zip file, so when you download it, put it somewhere and then extract it or unzip it, I guess it's called. When you right click, pick the option. Is it send to unzip? Right click on it.
Extract all.
Extract all. All of a sudden another folder opens up. It will look just like it normal. Go into it. Click on it. You can install it if you want. I wouldn't. Click on the executable file. It will open up and you'll get an error message. So then what do?
Right click, run as administrator.
That's right. Right click on it instead. Left click on run as administrator. It will work from that point on. You just double click on it after that. But that first time you get that error message, right click on the executable file. Left click on run as administrator. And then email me when you still can't figure it out.
Unless you have a Mac.
Unless what?
You have a Mac.
Yeah, unless you have a Mac. That's bad news. But you can get on. But you can get on Lab anywhere, right? All right. But not during the class. Shoot. I like to keep, even playing field, but I feel bad for the Macs. Sorry.
You can actually download a thing that will allow
Here we go.
you to partition your hard drive.
Yeah,
can
so
run
you have both
Windows
operating systems.
on a
But
small portion of it.
we
I don't
talked
know.
about that. Sean said he's not ready to do that. He has not experienced anything that technical yet, right? Is that what he said? Something like that. Yeah, he says he's not tech savvy. He doesn't think he can install a whole different operating system and partition a hard drive. Even though it's not that hard. But if you've never done it before, I can see where, am I supposed to be doing this? You know? So, partition a hard drive is a big deal. So there's the software. It's on your course information tab down at the bottom underneath our usual schedule and everything. All right, we got one more. Here we go. Let me see if this, does this represent, this is up, look at what kind of a problem this is. Why don't I tell you that? I'm going to throw some loops at you and see if you figure it out. 8, 30, and 2 are the right-hand sides, correct? You ready? Solution. Solve. Let me get over here. We got, dang, why won't this show up? I'm going to be able to see the whole thing.
Drag the corner.
Drag this corner?
Yeah.
Into this? All right. I thought it would make the other one disappear. I didn't know you could overlap them. I thought you had to have them side by side. All right. I forgot what I was doing, but here we go. Hang on. I'm almost there. All right. You ready?
Are you?
You're in your office. Yeah. And we just found out that our costs have just gone up, but we've already planned on 1.5 and 2 of whatever X1 and X2 represent. We've already got that plan in place. It's happening, but our costs, we just found out that our costs are going up. And so our cost that we're trying to minimize is for each variable is at 6 and 9 currently, but they're going up to 7 and 10. Instead of 6 and 9, they're going to 7 and 10. My question for you is the optimal solution still valid? And if so, let's calculate the new objective function value. Yes or no, is the optimal solution still valid? What do you look at first, I guess is what I should say.
100% rule.
Yes, and then 100% rule is not first. What's first?
Save some limit.
I couldn't hear you. Say it again.
See what's in your limit.
That's right. No, even though you recognize that 100% rule is in place, you still got to tell me something that says you check to see if each are within the limit. You've got to do that first. And 6 is going to 7, it's within its limit. 9 is going to 10, it's within its upper limit, right? This is the first time you're going to be divided by infinity. I look forward to this.
Do we write that we know it's within the limit? Like say,
Yeah.
Or do we
Yeah.
have to like
No.
literally show it?
I don't care how you do it. I write it, show it, however you want. I just want to see that you are telling me you check the limits. However you do it. For each change.
What would be an example of something that has no upper limit?
I have to think about it. I don't have one off the top of my head. I can't think of it. I don't know. I can't even imagine because this is a cost. How can there not be an upper limit on
That's
a
what I'm
cost?
saying.
I don't profit it.
What if it was like gold, and you needed gold to make your hard drive, so you
Yeah,
were
yeah,
willing
if this
to-
was a max problem, this would represent the profit off the hard drive we're making. The gold would be a resource, which would be down here. That would definitely be a but no upper, and here's no upper limit, here's a no upper limit on a resource, so that may be a good explanation again. But the gold will be so expensive, even though we're using it on motherboard, that we still may have an upper limit. I don't know. Okay, I'll answer your question when I think, I'll tell you what that. But at this point in time, these two changes took place. You said they're both within their upper limit, is that correct? Let's do the 100% rule real quick. How many unit change is this one? 1, it could be how many units? That's right, I see 6. This is currently 6, it could go up to 12. There's 6. 1 divided by 6 is 0.16666, I think. Confirm that. This one's going up to 10. How many unit change is this one? 1. How many unit change could it go?
Forever.
Infinity. Are you ready? Those who have calculators in front of them, real quick, take 1 divided by, I don't think you have an infinity key, so just put 9999 until you run out of spaces. Put 9999999. 1 divided by 9999999 until you run out of spaces. And then hit equals. And you should get 0.0 or 0.1 e negative 12 or something. That sound right? Negative 13? Oh, negative 29? Yeah, so negative, it'll say 0.1 negative 9, meaning that you need to add 29 zeros in front of it, 29 zeros, then a 1. So what I'm trying to say is, anytime, no matter what that number is, divided by infinity, it's pretty much the same as 0. It will be such a small number that you might as well call it 0.
Mine says 0.
It rounds it for you.
So on the quiz, you aren't going to give us these objective functions or experience. We have to come up with them, right?
No. This?
Yeah, we have to come up with those.
No. Not till chapter 1 you did, chapter 4 you did. You might have a problem, one problem that you may have come up with it, but you're going to have several problems where I'm giving you this, and I may not even give you this at all, but I will definitely tell you whether it's a min or a max.
But the thing is, can't you just double check if you actually have it correct because you can go off the current values and see if you actually got it right? There's no way to double check.
What do you mean? You saying you have to have this to be able to double check if you have it correct?
Yeah, because you can, just because the min and max, that was a min problem, has 6x and 9x2.
Yeah, but I can look at this and know that it's 6x1, 9x2.
Yeah, so I'm saying like, the
I
question-
want you to be so familiar with that output that you don't need this except with that word.
Oh, okay.
See, I can tell by looking at that, what the right-hand side, I can see what you're saying here though. It's not giving you these numbers.
Yeah.
That's the part it's not giving you. But this part you don't need for any of chapter 3 questions. All the analysis of the output doesn't use these numbers at all. It's just the right-hand size and the changes, and these current values in the objective function and their changes. Chapter 3 is all about what happens if this changes, that changes. You get called by a supplier. You have to make decisions fast. Where would you look? What does this mean? Hey, real quick, here's a perfect example that would be on the quiz if I wasn't saying this right now and giving it away. You ready? Out of these constraint numbers, which constraints are binding? Now look, my grandma answered this. She's not even alive, so come on. I mean, she was right there. This should have been an easy.
The first two.
That's right. No, wrong. Sorry.
Bottom two.
Not the first two. 2 and 3. 2 and 3 are binding because why?
No slack or surplus.
No slack or surplus. You guys got to have that somewhere. You got to be familiar enough with these outputs to go. Any constraints that have no slack or surplus are the binding constraints. In this case, the constraints 2 and 3. You didn't need the problem to see that. You just got to be familiar enough with these outputs to know where to find them. All right. And notice, only the binding constraints are the ones with the dual prices. Constraint, now, right, if I said to you, constraint number 1 has 2.5 what? Slack or surplus, you could not answer that question on this output. You would have to have that.
Yeah.
Yeah. And what would it be, slack or surplus, anybody?
Less.
What? Is that true? We're talking about constraint 1. Just checking. All right. The other two are greater than equal, not constraint 1. All right. And by the way, 2 and 3 are 0, but they're 0 what? Slack or surplus? Surplus, because they're both greater than equal. That's where you look. All right. How are we doing on review? There was one more thing I wanted to. We did the dual. Oh, we got. The only thing we didn't do here is the new objective function values. The only thing we got to finish on this, because this was definitely, if this question's on a quiz, it will say the optimal solution still value because this is objective function, and what's the new objective function value. So let's calculate it. I'm going to do the fast way because you could take 7 times what? No, 1.5, and 10 times what? 2. It's the corresponding values for the objective function times the optimal solution for the values of x1 and x2 up there. Added together is that objective function value, 27. So if this is going up 1, will the objective function value go up or down? Up. If this is going up 1, will the objective function value go up or down? Up. It's not like the right-hand side constraints where you got to go, wait a minute, is it a positive effect, negative effect, do I add or do I subtract, depends if it's a minimize or max. The objective function changes are telling you exactly what direction. If they're going up, you're adding. If that's going down, you're subtracting. You don't have to worry about the dual prices and whether it's min or max. So they each went up 1, so I'm going to take 1 times $1.50, and the other one is 1 times 2, and I add them to the objective function. So $27 plus $1.50 plus 2 is $30.50. And there's the new objective function value. I just took the 1 unit increase times their optimal solution. I want to say it one more time because this will kill you if you don't have this down. Changes in the objective function numbers are always related to the optimal solution. Changes in the right-hand side of constraints are always related to these dual values, dual prices, whatever you want to call them. You got it? All right. One more. Here we go. See the 30 and the 2 down at the bottom there, the right-hand side. Only about 25 units showed up to the dock of constraint 2's resource, whatever that resource is. And constraint 3's resource, 3 units showed up to the dock. Are you ready? Are the dual prices still valid, yes or no?
Yes.
Oh
No.
boy. Oh, look at you guys. Man, you said it with confidence too. That's what scares me. Right? Like you knew it. You were on top of it waiting for the question. Check it out. We have more than one change taking place. First step, check if they're in the range, within their limits, which I'm sure they had looked at, and they said yes right away because they already had looked if they're within their limits. And they are, correct? This is going down to 25 from 30. It could go all the way to 15. Real quick, how many units is it going down? 5 units, and it could go down how many units? 15. Oh, you made me right. I thought that was more. Okay, this one's going from 2 to 3, which is 1 unit. It could go up how many units? This is obviously 0.5. I thought this was more. That's a question. Did you guys already do this in your head?
Oh, yeah.
Oh, yeah, right. This is 0.333, I think. That's 1/3, it looks like. Add these together, I get 0.8, I get 0.888, is that what that is? 0.83, excuse me, 0.833333, right?
Yeah.
Is that what I'm at? I'm putting on here that I'm comparing it to 100%, which is the same as 1.0. You can write 100% or 1.0, they mean the same thing. I've compared it, I know it's less than. Now, are you ready? Let's calculate the new objective function value. It's currently 27. What do I do first? I've got a, what kind of a change do I have with constraint 2? How many units? 5 unit change. You said the dual price is still valid. What's the dual price for that constraint? How much? Can't hear you. What's the dual price for that constraint that we just took from 30 to 25? How much? Negative 60 cents. Negative 60 cents. Okay. Do we add or subtract the 60 cents times our 5 units to this $27? Add or subtract it? Oh, you guys, let's stop right here. All right, let's stop. The dual prices, I don't know. You got to remember this. Ready? I don't know how else to say this. Always represent the effect a 1 unit increase will have on the objective function value. Do you hear that? Always. The dual prices represent, and I'm stating this as if I think I heard a mistake, and now you guys are looking at me like I'm all confused with you. But here we go. The dual prices always represents the effect on the objective function value if there's a 1 unit increase. We're not increasing, correct? We're decreasing, right? So it will have the opposite effect. It's a negative 60 cents, not a negative effect, a positive effect. Now do we add or subtract?
Subtract.
Why? Well, not just because it's going down.
It's a min.
Because it's a minimization problem. And a positive effect on a minimization problem would be lowering costs. Minimization always represents cost. So a positive effect would be lowering costs. 5 times 60 cents is what, $3? Is that right? Next, the 2 is going up 1 unit. What's the dual price for this change from this resource? I see it. What is it? Come on, Nick.
5.
Go ahead. Say it again. Negative $4.50. And this is a 1 unit increase. So it's supposed to have a negative effect of $4.50. Do I add or subtract that $4.50?
Add.
It's a negative effect. What? This was a positive effect. So a negative effect would add $4.50, so I got to subtract 3, that takes me to 24, add 450, takes me to 28.50. Those two changes. One having a positive effect, the first one, because it went the opposite direction, and one having a negative effect, because it did increase, and it's supposed to have a negative effect. Minimization problem means add to it for negative effect, increasing cost. Anybody lost? Did I make a mistake?
I'm confused where the 3 came from.
Which 3 is that? This one?
Yes.
You ready? 5-unit decrease times 60 cents.
Okay.
So what is that? Is that $3? Help me out. 60 and 60 is $1.20.
60 cents.
Is that $3? Okay, so $3, but and then I'm subtracting it because it's got to have a positive effect. And it's a minimization problem, so subtracting from cost would be a positive effect. Always look at that decision, whether you add or subtract from a manager's point of view. If this is a minimization, a positive effect would be lower the better. If this is a max, a positive effect would be higher the better. So look at it from that kind of a point of view. How are we doing? We're almost done? By the way, that supplier called back and they said, we're so sorry that we forgot to drop off those 5 units. We're on our way with the 5 units right now. Hang on, I'm almost there. We're on our way with the 5 units right now, and we have an extra 10 coming. Now, don't let this confuse you. I've never written a question like this, but don't let it confuse you. We're bringing back the 5 you already expected, and we happen to have an extra 10. Everybody with me? Ooh, this is a bad example. We have an extra 10 that we're going to give you for free because of our mistake. Wait, I can't do that. That's bad. For $1 per unit. $1 per unit. How's that? For $1 per unit. And it's a sunk cost. Do we take it or not take it?
Not sure yet.
He's enjoying this.
Wait. Wait. Forget it. It's a relevant cost. Now this makes sense. I like this. Relevant cost, and we usually pay $1 each. What's it being offered per unit? I forgot.
$1.
We usually pay $2 each. Okay. All right, let's go. Here we go. This is good. This is good. You're writing notes? Is anybody recording this? Is it running? Make sure the numbers are turning, because I want to make sure you guys get this.
Oh, yeah.
You ready? Here we go. We were expecting 30 units of this resource, right? Only 25 showed up. We got a hold of them. They're still on the road. They're coming back to bring us our 5, and because of the situation, we have this opportunity to buy 10 more units on top of that for $1 per unit. Is that what I said? For $1 per unit. It happens to be a relevant cost, and we usually pay $2 for it. Do we say yes or no to those extra 10 units? Alexis, come on. I know you know this. I can tell by your look on your face that you don't know it, but I know you do know it. Oh, yes or no? Do we take it?
Yeah.
Anyone else? You say yes after you negotiate. That's what he wants to add to it. She's saying yes? Cheyenne? You gave a look like you knew the answer.
No, I was with confusion.
Oh. Anybody else feel like they know the answer? Come on.
Screen went down.
Huh? There you go. She says yes also. Again, Justin says after we try to negotiate. Okay.
Because we would just take the $2, subtract the 60 cents, take us down to $1.40.
Everybody hear
Right? So
this?
if it's less than $1.40, we would take
The
it.
relevant cost says always look at the dual price and combine it with the regular price. We usually pay $2 for it. It has a negative 60-cent dual price. Combine them, what's the most we're willing to pay per unit? $1.40. It's being offered to us for how much? $1. The 50 has nothing to do with it. You can just ignore that part. The 5. They're bringing back the 5 because we already had that in here. This already represents that 5 they're bringing back to us that they accidentally didn't drop off. Yet all the decision you have is all based on that extra 10. And if they're offering it to us at a price we're willing to take it for. Because the word said relevant cost and the usual price is $2, you say relevant cost means the dual price represents the amount I'm willing to pay premium over and above the regular price. And if it's a negative, it means you're not even willing to pay regular price for it. They have to offer it for less than regular price at least 60 cents less than regular price for it to even benefit you as a company. And they're offering it for $1 less than regular price, so you're taking it.
But $2, is that the current value? Is that what you're giving?
No, I wrote $2 right here, as if this were a pretend hypothetical problem. It would say in there, and usually the cost is $2 per unit, and it's a relevant cost. It would be in a sentence. That's part of the problem.
Can you explain how you got the relevant cost, how do you know why it's one time?
It will say in the problem, relevant cost. In real life, you gotta determine whether that cost is already built into the objective function or not, based on how these numbers came about in real life. I'm not gonna quiz you on that. I'm not expecting you to be able to calculate what the.
Oh, I meant like the example you just gave, can you explain like
Oh,
when, where?
how you'll know if it's relevant or sunk?
Yeah.
You'll know because the problem will say it's a relevant or sunk cost.
But where did you get the, I think if you were asking, where did you get the $1.40?
Yeah.
Oh, okay, ready? The problem says it's a relevant cost, and we usually pay $2.
Yes.
Because it says relevant cost, and we're being offered 10 extra units, each unit would cost us $2. The most we're willing to pay, because it's a relevant cost, is the dual price as a premium over and above the regular price. So you would add them together. Just like if that were a positive 60 cents, or which one are you doing?
Yes.
If that were a positive 60 cents, the most we're willing to pay then is $2.60.
Okay.
But because it's a negative, the most we're willing to pay is $1.40.
That makes, okay.
Because it's relevant, you gotta put them together. If it's sunk, you're looking at that. Now, if I made that a sunk cost, first of all, if it were truly a sunk cost, it would never be a negative. But if it were, you would say, it doesn't matter what price they offer it at, a sunk cost, that's the most we're willing to pay, which is where they would have to pay us 60 cents to take it. What are the odds of that, right? You know, so that's how you would interpret it. Relevant or sunk. The regular price, if it's relevant, plus the dual price as a premium. If it's sunk, just that dual price, which would be a positive number if it were sunk cost.
So when would we ever run into where we're going to have to pay a situation where we're going to have to pay more than what we normally pay?
A premium? Oh, if it's already built into here, but it could still, and it happens to be a binding resource, we're willing to pay extra for it because we know how much
Gotcha.
profit it will bring us.
Gotcha.
And this is really, if this were positive, it'd be telling us how much profit we'll make for every additional source, even though it's already built into that 69.
Like the gold thing she said earlier, if the price of gold
Yeah.
went up, we knew it could go up, for example, 60 cents, and we'd be willing to pay
That's right.
$2.60
That's right.
to be able to, okay.
Because we'll still make profit on it.
Okay.
That's
And
right.
then can you, or how much would it cost for us to get you to post that table that you had said that says if it's a min
I never
negative
make that
effect?
table. I said I've seen students, all kinds of different tables made by them, but I have been very aggressive in my suggestion this semester, which is I'd make a table for a minimization and a table for a max, and I wouldn't mix them. And I would look at the problem to decide whether I add or subtract on using that dual price, positive or negative, whether you add or subtract. I would go to my two tables, because hopefully having two tables will get you to go, okay, is this a min or a max, and then go to that correct table. And then you know whether to add or subtract. That's how I would do it. I've never made one for students before. That's not like me. But I do offer open book, open note. There's no way everybody does that, do they? Does every class you have an open book, open note class? No. Yeah.
Oh, really?
Good. All right, is there anything else you guys want to talk about? The only other you guys, I'll see you at the test. Email me. Practice some problems at the back of the chapter if you want. You need the answer, email me. I'll send you the answer to it on the back. Send me questions if you want. Let me know.